All right, so I'm Glenn Berry, and I'm a services database engineer at Kerber Supply Chain Software. And this is Dr. DMV's Troubleshooting Toolkit. And this is my Yay Me slide. The most important thing here is my email address, and then also my Twitter handle. And I've also got a YouTube channel. And I know how to brew beer. I've been doing it for about 7 years. I'm a pretty serious home brewer, but that's not what you came to hear about probably. So anyways, what we're going to talk about tonight is my diagnostic query history, a little bit about the queries and then how they're structured and how you use them. And then I'm actually going to spend most of the time tonight demonstrating how they work and how you interpret the results. So if you're a DBA, you know that people tend to notice performance issues on the database. And DBA really stands for default blame acceptor. And the database is always guilty until proven innocent whenever there's any kind of a slowdown on your website or application. And I got tired of hearing that. What's wrong with the database? What's wrong with the database? And that's why I developed these queries many years ago. And DMV queries first came out in SQL Server 2005. They've been out for a long, long time now. Each new version of SQL Server adds new DMV queries and new columns to existing ones. And they give you a lot of really useful information about your configuration and your workload and your performance information and what your bottlenecks are. One big thing about them is that they're not persistent like query store is. So if you restart SQL Server, it clears out all the DMV information that's been gathered up since you last restarted. And these diagnostic queries, I first started making them public back in 2009. And every month since then, I do updates. And sometimes it's just some formatting, but I add new queries sometimes and just clean things up and improve them. So I use them pretty much every day myself. So that's why I maintain them. And there's separate versions of these queries for each major version of SQL Server from 2005 all the way to SQL Server 2022. And there's also a separate version for Azure SQL Database and Azure SQL Managed Instance if you're using either one of those. And the way these things are structured, the first roughly half of the queries are instance level queries. So it doesn't matter what database you're connected to. But then roughly the second half are database level. So it's really important you're connected to the database that you care about instead of master. A lot of people will run these queries and then get all this stuff about master, and that's not very useful in real life usually. And then there's lots of links and notes and comments inside the queries that point you to more information about that query and just best practices and KB articles and blog posts and things like that. So it's kind of a useful resource that way. So you might be wondering, okay, where do you get these amazing queries? Well, they're on my blog and they're 100% free. I don't collect contact information. And so you can see, glensqlperformance.com/resources or the bit.ly link there. And I've given Harry the PDF version of this deck, but just Google Glenn Berry DMV and you should be able to find it no problem. So I told you the PowerPoint would be quick, and that is it. Now we're going to actually get into the queries themselves. And these queries, again, there's a different version for each major version of SQL Server. And before I actually jump into the queries, I want to show you one other real quick thing. There's a new feature in SQL Server 2022 called QAT backup compression. So I just want to take about 30 seconds or a minute and demo that real quickly. Hopefully nobody minds too much. But I've got a database on my workstation that's about 40 gigabytes in size, okay? And you can take a look there, and it's divided up into several different data files spread across different drives. So it's not, it's not AdventureWorks, but it's not a huge database. And it's an AMD system, and I don't have any Intel QAT hardware. And so I want to make sure that's clear because you can do this in software mode if you install the QAT drivers. So when you run this little DMV, it shows you what's going on with QAT. And right here, it says software mode accelerator hardware not found. So that tells you it's going to use software mode. And then I'm just going to take a backup of that database. And the first backup is going to use the old legacy Microsoft Express backup compression. And so now I'm running it, and it's running, fairly quickly for a 40 gigabyte database on my system. And it's going to probably take about 20 seconds or so to finish. And this is a striped backup, by the way, to 4 backup files that are all on the same drive. So that took 20 seconds, about 2007 megabytes per second with regular old backup compression. And now I'm going to run a backup of the same database with QAT backup compression, just using software mode. And when I do that, it should be significantly faster. It's typically about twice as fast. And the reason why, in this case, it was not quite twice as fast, but almost, it finished in 11 seconds for a 40 gigabyte database. And the reason why it's faster is using the Intel QAT compression libraries, and it's still using your regular CPUs to do the backup. And you can check and see what it's been doing right here real quick. So you can see the uncompressed size, and then the QAT backup compression is slightly smaller. And you can see right here, QAT deflate, and then here's MS Express. So this is a feature that works in SQL Server Standard Edition without any Intel hardware. So I just wanted to show you that because I spent a lot of time helping David Pless at Microsoft test this over the summer, and I know the feature really well. So anyways, hopefully you don't mind that quick detour. So, all right, so I'm going to go ahead and get into the real DMV queries here. So here's what it looks like for SQL Server 2022. I'm going to run this against SQL Server 2022 on my instance. And the way it's set up is that there's an initial query at the top that's just there to kind of double check that you're actually on SQL Server 2022. Because I get a lot of emails where people say, no, it doesn't work. Because that's usually because they have the wrong version. Some of the queries won't work. So the first real query is right here. And the way this is set up is it shows you kind of a short description of the query, and then the query number, and then the name of the query. And then there's 6 dashes right here. And all this stuff is in here because people around the world have written automation solutions with PowerShell and C# to automate, parse and automate running these queries. So that's why this format is that way on purpose. And when I'm doing this in real life, looking at somebody's server, I usually run these manually, which takes typically 45 minutes to an hour to run them and save the results to the matching spreadsheet. And as I'm doing that, I'm getting a feel for how the database is reacting, and I'm taking notes. So that's why I do it that way usually myself, but some people don't have time to do that. So there's automation solutions. So anyways, go ahead and just run the first query. And this simply tells us the name of the server. This is a named instance, and then all the version information about SQL Server and your OS. So I know that I'm SQL Server 2022 RTM Developer Edition on Windows 10 Pro, and it's 64-bit. So that's kind of nice to know because there's a lot of differences between Enterprise Edition and Standard Edition, for example. And then I maintain a little build chart right here. So far, CU1 has not come out yet, and Microsoft is late. They're about 3 weeks late already getting CU1 out. But anyways, the next query in this set is looking at the error log. And not all these are actually DMV queries, by the way. So this is just reading the error log. And this tells us how many cores and sockets we have in the machine and how many are being used, because sometimes people will install Standard Edition on a VM that it's more than what you can do with Standard Edition. So more than 24 cores, for example, and you'll catch that here, for example. So that's one reason it's useful. The next one in the set is looking at server properties. So this is just calling the server property function multiple times with different parameters. And this tells you a lot of useful information about your instance. So the machine name and the instance name, whether or not it's in a traditional failover cluster, Again, all the information about the addition and the build. You get things like the collation. Is full text search installed or not? What's going on with file stream? What's going on with AGs? Are they enabled at the instance level? This is kind of useful. It shows you the default data path and log path and backup path, where the error log lives. And then other things like for newer versions of SQL Server, is TempDB have metadata memory optimize enabled. And these two on the far right are brand new for SQL Server 2022. So that's what that shows you. And again, the reason you're using this in many cases is you're looking at a strange server that somebody else set up, and you're trying to figure out what kind of shape is it in, what's wrong with it. So the next one is going to look at configuration values. And when I run this is basically SP configure. And certain ones that I key in, like backup compression algorithm is a new one. Backup checksum default has been around for a while, and backup compression default has been around for a while. And then is the CLR enabled, for example? What's cost threshold for parallelism? The default is 5, which is often too low, depending on your workload. Other ones that are really important, in my opinion, are max degree of parallelism and max server memory, and then cost threshold for parallelism, which I think I already mentioned, and max server memory, and then optimize for ad hoc workloads. I usually think that should be enabled for most workloads, but this shows you what's going on. And then the next one is just DBCC trace status -1, which shows you all the global trace flags. And depending on what version of SQL Server you're on, certain ones are a pretty good idea just for pretty much every single instance. And this is my opinion of what's good for SQL Server 2022, 3226 and 7745. And I've got comments right here and links that explain what those two trace flags do. Each newer version of SQL Server doesn't need as many trace flags as old versions did, because the behavior is on by default in most cases. So then the next one is process memory. And this is showing how much memory is SQL Server actually using, because you can't believe Task Manager. So this tells me I'm using about 36 gigs of RAM. And then this 0 right here tells me that lock pages in memory is not enabled. And that's on purpose, since this is my workstation. It's not a real database server. But if it was a real database server, I usually want to enable lock pages in memory. And this would show you whether it's enabled or not. So then the next one is going to show us stuff about our services. So the database engine and SQL Server agent. And it tells you what's going on with them. And here's the important thing. How long has it been since SQL Server was last restarted? Because you need to know that when you're interpreting some of the other queries later on. If you've been just running for a few hours or a day or two, or has it been 6 months? And then over here at the far right, it shows you instant file initialization, whether it's enabled or not. And you want that to be enabled pretty much in every case. The only reason it's not enabled by default is there's a tiny, tiny security risk associated with it. And it's only a risk if you do a whole bunch of stupid things at the same time, which hopefully you're not doing. So this next one is extremely useful, last backup by database. And I use this all the time because I spend a lot of time fighting disk space issues and runaway transaction log issues as I take care of databases at Kerber. So when I run this, this shows all the databases on the instance and what their recovery model is and what their log reused weight description is, and then how big is the data file on disk, and then how big is the log file on disk, and how much of the log is used. And then if we scroll over to the right, it shows when was the last full backup and how big was it, which is kind of nice to know. And then with 2022, it shows you the backup compression algorithm that was used for the last full backup. So you can see that was using QAT and the rest were using old-fashioned MS Express. And then it shows you your differential and log backup, and your last valid restore time is another new column for SQL Server 2022. And that only works if you're using full recovery model, because it looks at when the last transaction log backup finished. And it's usually a little bit before that. So it shows you actually where you could restore to in a point in time. And then this shows you the last time that CheckDB was. So that's a good, quick and dirty overview of what's going on with your databases. And paying attention to this will help you catch things before they cause big problems. All right, the next one is new for SQL Server 2022. It's that accelerator status one that I showed you earlier. And again, right now, they just have quick assist technology, but Microsoft has said that they're going to probably add additional accelerators in the future. And you might have heard of Intel Sapphire Rapids, which is actually released yesterday, or they had their big product announcement. And there's going to be additional accelerators that Microsoft might use. And plus, they might use accelerators from AMD or other third parties in the future. All right, this next one is looking at SQL Server agent jobs. And this will show you what's going on with your agent jobs real quickly. And I don't have that many here. I'm using the Ola Hallengren maintenance solution, which is a really good thing to use. It's free and it works very well. But it shows you your job names and the description and who owns them and what the schedule is and what was the last duration. And so you get some good information about your agent jobs right there. And then the next one is SQL Server Agent Alerts, which a lot of DBAs don't even know they exist. But you can create alerts. And then when certain bad things happen, you can have the alert fire and have it run an agent job or send an email or run some code to try to fix the problem. And this is a good idea because a lot of these things are pretty bad. And when they happen, normally you just go on the SQL Server error log and you might not notice them. But if you have this alert in place, you might find out earlier. Okay, the next one is host information. And this shows you what's going on with the OS that you're running on, whether it's Linux or Windows. So if it was Linux, it would show you which distribution of Linux. And in this case, I'm on Windows 10 Pro and I'm using 64-bit and it's English. So that's fairly typical in the United States. All right, the next one is going to show us what's going on with NUMA as far as SQL Server is concerned. And this is handy to know because a lot of times people will install SQL Server on a VM, for example, and they get the NUMA configuration all wrong. Or they install standard edition on a machine and they exceed the license limit. So what'll happen is you'll see 24 schedulers on one NUMA node and 0 on the other NUMA node, for example. You want them to be balanced here. And since I've got a Ryzen 9 5950X, that's why it's shown up with 2 NUMA nodes that each have 16 schedulers. All right, the next one is going to show us what the operating system thinks about memory. And this shows us how much physical memory we have. So I've got 128 gigs on my box, and I've got this much available. But the important thing that I always look at is right over here, the system memory state. And that tells you there's an OS level flag that gets set. If the operating system is under memory pressure, it'll say available physical memory is steady or low. And that means it's signaling all the services and applications to release some memory. And you don't want to see that. And the way you fix that is to lower your max server memory setting in SQL Server or give more memory to the VM or physical machine that it's running on. Okay, the next one is if you had an old-fashioned failover cluster, this would tell you what's going on with it. So I'm going to skip that since I don't. And if you had an AG, this would tell you a little bit about the AG nodes. And I'm going to skip that. And then if you had AGs, this would tell you what's going on with your AGs as far as health and synchronization status. So I'm going to skip that. So the next one I'm going to actually run is just some hardware information about either your physical machine or your VM. So again, I've got 32 logical CPUs and 16 physical cores and 1 socket and 2 NUMA nodes. And here's how much memory I have. And it tells you again when SQL Server started and how many hours it's been running. And then virtual machine type, none. You can't always believe that. Sometimes it'll come back and say VM. That just means there's a hypervisor installed, which you may or may not be running inside of. And that when it says conventional here, that means lock pages in memory is not enabled. You want it to say lock pages over there on most real servers. All right, then the next one is looking at the error log to find out, okay, here's how you know if you're running in a VM or not. And in my case, I built this machine from parts. It's an Asus motherboard. So it just says this. But on a real server or on a VM, it would tell you Microsoft Hyper-V, for example, or Dell PowerEdge R740, whatever the machine is. So that's how you find out for sure if you're running in a VM or not. And then the next one is only useful on a physical machine as opposed to a VM, but it tells you the main BIOS date. And in my experience over the years, a lot of administrators are really, really bad about keeping their BIOS up to date on their physical hosts. And this would help you figure that out, assuming you're not virtualized. And then the next one is super important. It shows you exactly what processor you're running on. And I know a lot of SQL Server DMV, DBAs, I should say, they could care less about this. That doesn't matter. I don't make that decision, but you should know what you're running on. Is it new and fast, or old and slow, or new and slow? And now that you know the model number of the processor, you can Google it and figure out its specs and how old it is. And that's super important to understand. So here's a new one for SQL Server 2022. They added support for AVX 512. And this query that I put together helps you understand what's going on with that on your machine. So when I run it, it tells me what build I'm on and what edition, because AVX 512 support only works on Enterprise Edition. Then it tells you what processor you have. And then it looks in the error log to figure out what level of AVX support you have. And this is a Zen 3 processor that doesn't have AVX 512, but Zen 4 does. So the AMD Genoa server processors have it, and then the Zen 4 client processors have it. So they would say AVX 512. And then even if you have it, Microsoft makes you enable trace flag 15097 to turn it on, even if your processor supports it, because they're being very careful about it. And you might say, well, why do I care about this? What's the point of this? Well, the only thing that it's going to help you with is certain column store queries right now, but they may add support for additional things in the future. They're being really, really tentative about it, but that's how that works. So then the next thing is you want to check and see if I had any memory dumps from SQL Server. And hopefully the answer is no. But if you run this and it comes back with multiple rows, it'll show you the name of the memory dump and when it happened and how big it was. And if you know what you're doing, you can go crack it open with WinDebug, which I don't know how to do. But you can also look at the text files and try to get an idea of what might have caused it. And if you're seeing a lot of memory dumps, you want to make sure you're up to date on your CU. And if you're still seeing them, then you might want to open a support case with Microsoft. So then the next thing is looking at the suspect pages table in MSDB. And this will help catch early signs of corruption. And you want this to be empty also. And if you open this up and you see lots of rows in here, you have a problem that you need to investigate. Because what's happening is it's having bad checksums or torn pages that are sometimes being corrected and sometimes not, but that's not good. And it's very unusual to see anything in there. And if you do, you want to do something about it.
Hey, Glenn, I do have a quick question. Since you says like you can use this to catch uh to catch corruption before it happens, are you suggesting that we run this in kind of like a frequency job that says like, oh, hey, check this every so often?
You could. I mean, what you
Yeah,
really should be doing is running dbcc check db
obviously.
often.
Uh-huh.
That's actually doing the right, a full check. But
Yeah.
this is another thing you can do in addition to that.
Okay.
So if you're running DBCC CheckDB, you probably don't need to worry about this as much, but I think it's a good idea to run it.
Okay.
Because some people don't run DBCC CheckDB because they've got huge databases and they're worried about the resource usage, for example.
Right. Okay.
Okay. So then the next query in the set is just looking at your SQL Server error log and pulling back, some of the most recent entries. And it turns out that SQL Server 2022 is very chatty. And some of this stuff in here is kind of annoying, and they'll probably clean some of this up with CU1 or in the future because people will complain about it. But there's a few new things that show up here too, like right here. This is something new that Microsoft hasn't really told us what it means yet, but it shows up in the error log. So it's kind of useful to look at the error log from time to time and see what's going on. All right, then this shows you how many data files does tempdb have. And all versions of SQL Server since 2016 let you get this pretty close to correct when you install SQL Server. But if somebody, didn't do that or skipped it, you might come in and just see one data file, and that can cause performance issues on older versions of SQL Server. Microsoft claims that you don't really need to have multiple data files as much as you needed to in the past with 2022, because they made so many improvements to tempdb. But this shows you what's going on with it. And you want to make sure they're all the same size and they all have the same auto growth increment. And then something else I just added in the last month or so is this one right here. It turns out that ever since SQL Server 2012, it checks whenever SQL Server starts to make sure your tempdb data files are configured with the same initial size and the same auto growth setting. And if it's not, it writes it in your error log to tell you about it. And most people don't notice that. So this will help you look for that. And you want this to come back with nothing like you see here. But I find a lot of servers have something messed up. So one of their tempdb files is really big and the rest of them are much smaller. And if that happens, SQL Server will tend to just use the large file and ignore the small files. And that causes increased allocation contention, especially on older versions of SQL Server. So you want to catch that and fix it. All right, this next one in the set is database file names and paths, and it's going to show you how all your database files are laid out across your instance. And the file ID 1 is your primary data file, and then 2 is your log file. And then you might have additional files, but it shows you where they live and how big they are. And then right here shows you if any of them are using % growth, which is bad. And so, for example, this old AdventureWorks database is using % growth and it's set to 10% for the log file. And so it's going to grow in tiny slivers at first, and then it's going to start getting bigger and bigger each chunk. And you don't want that. You want to change it to a fixed size, like 1,000 megabytes, for example, to minimize your VLF counts. And the guidance on that's actually changing for SQL Server 2022. It turns out that log files can use instant file initialization in SQL Server 2022. They couldn't do it before, but in order to do that, the auto growth has to be under 64 megabytes. And if you have smaller log growths, it only adds 1 VLF in 2022. So they've changed that to make it a little bit better.
Oh, wow.
Right.
That's great. I did not know that.
Yeah.
Because for the longest time, it was only for data file, right?
Yep, you're right. It was only for data file for a long, long time.
Yep.
So the next one is going to look at all the drives that the operating system can see on your machine and what's going on with them, how much space they have available. So I've got these 4 drives on my machine. And then the next one looks at all the drives that have SQL Server database files on them and what's going on with them. So you get some more information about them, how big they are and how much space they have available and how much percentage they have available. And depending on what kind of drive you have, it's bad to be running low on space, not just because you're going to run out, but it actually hurts performance, both with magnetic drives and with SSDs. They don't perform as well, regular NAND SSDs, when they're close to being full. So the next one is going to look at the drive level latency since SQL Server was last restarted. And this number is going to be higher than normal on most systems because it's looking at everything that touches your database files. So not just your regular workload, but things like backups and running DBCC check DB and doing index maintenance. Anything that ever touches the file is going to affect these numbers. And these numbers are all nice and low on my workstation with really fast drives. In real life, you'll probably see higher than this. And then you can drill in to the file level, which is actually usually more interesting. When I do this, it shows you every database file on your instance and how big it is and what its latency is. Excuse me. And some other information about it in terms of number of reads and number of writes. And if you're using Resource Governor to control your IO, it would show up right here. So this helps you figure out, for each database file, is it more read intensive or more write intensive? And that's going to help you figure out things like what RAID level should you use? How aggressive should you be with data compression? How aggressive should you be with adding new indexes, for example, if you know that sort of thing, instead of just guessing. And then the next one, because those last two queries, a lot of times you might run those and see really high latency. And then you go to your SAN administrator or storage administrator and show them, they say, oh, I don't care about that. That's just SQL Server. The SAN's fine. But if you run this next query and it's looking for 15-second IO warnings, if you have any, you want to look and see, is there a pattern? Is it always happening at 3 a.m. when you're running DBCC check DB or backups? Or is it happening all over the place at different times of the day on different files? But a 15-second IO warning is a really, really bad thing. And if you're seeing lots of them, that's really strong evidence that your storage is performing very poorly. And it's a lot harder for your storage admin to blow that off than it is some other things. All right, the next thing is Resource Governor. And Resource Governor is really underutilized, not because it's Enterprise Edition only. Not that many people use it in my experience, but it can be very useful in some scenarios. And this shows you what's going on with it. I'm not using it here on my workstation. So the next thing is your database properties. And this one is really useful. And I tell you, when I run this on almost any instance, I find so many things that are wrong. So when I run this, it shows you the database name for every database on the instance, who owns it. And this is on purpose. This is not good. Usually you want SA to own it instead of a login. And then the database compatibility level. This is very important on modern versions of SQL Server. Back in the old days, before SQL Server 2014, this didn't really matter very much. But now, and with each new version of SQL Server, it becomes more important. Lots of features are turned on or off based on this. And it controls what cardinality estimator you use by default. So it's very important that you think about what you have here and don't just leave it at 100 because you don't know any better, because you're going to miss out on a lot of improvements if you do that on a modern version of SQL Server. Then it shows you your recovery model and your log reuse weight description, and then what's going on with your data file and log file. And then your page verify option should always be checksum. It shouldn't be torn page or none. Then it tells you some other useful things that a lot of people just blow over. So mixed page allocation is a fairly new feature that should be turned on. I think auto update stats asynchronously should be turned on in most cases. And then another one that's super important is target recovery time in seconds. You want that to be a non-zero value, because if you do that, it enables indirect checkpoints on SQL Server 2012 and newer. And it really helps a lot of operations run faster, and it gives you better IO performance in most cases. And what happens a lot of times is somebody created a database on SQL Server 2008, for example, and it got upgraded over the years. And then you see it in here running on SQL Server 2022, and you see a 0. And you want to just change that to 60. And that's going to make a big difference in performance quite often. And that's a very easy thing to change. And then you also see other things like, is CDC enabled on the database? Is it a replication publisher? Is it a replication distributor? If you see anything here under group database or replica ID that tells you it's in an AG, are you using delayed durability? Are you using Query Store? Query Store is very, very useful, and a lot of people are still afraid of it. But if you're on a new enough build of SQL Server 2016 or newer, it's perfectly safe and it's very, very useful. And there's a bunch of new things that were added in SQL Server 2022, like these ones. This tells you if you're using TDE, transparent database encryption. So a lot of useful stuff there. All right, the next one. This one is also very valuable, but it's also very dangerous, and people do stupid things with the missing index query. So this shows you all the missing indexes that the query optimizer thinks that it would like to have across the entire instance. And this index advantage here is a calculated number that's based on how expensive it is not to have the index, and how big the table it is, and how often that it wants that index. And whether or not 30,000 is significant or not depends on your workload and how long you've been running. If I've been running for weeks, 30,000 is probably not significant. But if I've been running just for a day or a few hours, this could be pretty significant. And then this tells you the last time that it wanted that. And you want to look at that and then run it again and see, did it update? Because if it's updating every few seconds or every second, that means it's part of your regular workload, whatever query is triggering that request, and it's probably more important. And then this shows you your database and schema and table where it thinks it wants that index. And then this tells you how many missing indexes for that table total and how many are similar, which we'll get back to in a minute. And then if we scroll over to the right, on SQL Server 2019 and newer, it actually shows you the short query text. So you know what store procedure or query is triggering this request, which is really useful. On older versions, you didn't know that. You had to try to figure it out other ways.
Hey, Glenn,
Go ahead.
we have a question. Kurt is asking, can we see history of the last seek date?
Well, over here, the last user seek is right there. And there's no history.
Yeah.
I mean, every time you run this, it just shows you the last user seek. You lose the history. I think there might be other ways of figuring that out, maybe in Query Store, but this just shows you it updates every time you have another execution of the query that triggered it.
I do this, Kurt. What I was thinking about, is there a way to record it like every n number of seconds to see whether it's increasing or whether it's being up frequently?
Well, you could just run this query every n number of seconds and collect that column if you wanted to. Yeah.
Okay.
You could just strip this query down to make it do what you want to do. But the DMV just shows you the last user seek. So it'd be up to you to run it and record it somewhere else if that's what you wanted to do. All right. So getting back to this average user impact is the percentage that the query optimizer thinks that the cost of the query would be reduced by if you gave it this index. And the average total user cost is how expensive it is not to have it. And this is basically tied to how large the table is. And this shows you how many times it's wanted that index. So if you see really big numbers here, that tells you that it's happening more often. But all these things are calculated together in a little formula to come up with the index advantage. And so you want to look at the top here. But the one thing you don't want to do, and the reason why I said this is dangerous, is I've had people come up to me at the past summit, for example, and say, hey, Glenn, I like that missing index query, but I modified it a little bit to automatically create every single thing that it finds. Was that a good thing to do? I was like, no, don't do that. What you want to do is usually when you run this in real life, it'll come back and say, you want 10 indexes on this event log table. And if you look, quite often they're very similar what it thinks that it wants. If you look at the columns that it's asking for. And so you want to see if you can combine several narrow indexes into one wider index. And then the other thing to be careful about is you can't believe the order of these columns. You need to check the cardinality of those yourself if you want to be more accurate and decide what order to put these columns in when you create an index. And it only matters for the equality columns and the inequality columns. The order of the included columns doesn't matter. So that's kind of how you a little bit more intelligently use this. But the one thing you should not do is just lose your mind and run this and create 100 new indexes. Usually that's not the right thing. Usually I run this on a database and create 2 or 3 indexes at the most in most cases, and then go and check it later and see what else I have to do. All right, the next one is virtual log files, VLF counts. And this will show you for all your databases how many VLFs they have. And 167 is pretty low. And the reason you care about this is that if you have, above about 1,000 VLFs, it starts to affect the write performance of the log file, and it makes crash recovery take longer. So every time SQL Server starts up, it takes longer because of the VLFs. And if you fail over to another node with a failover cluster, it takes longer to come up because of that. And if you restore a database from a backup, it takes longer to restore because of a high VLF count. So there's lots of reasons to control that. All right, the next one is going to show you which of your databases are using the most CPU. And when I run this, it shows me this one right here is using 87% of the CPU. But this can be inaccurate sometimes because it's looking at the query plan cache. And if the cache just got flushed for one of the databases, it's going to throw these numbers off, but at least gives you a starting point to look at if you're under CPU pressure. And then the next one does the same thing for IO utilization. It shows you which databases are using the most IO for reads or total, and then for reads, and then for writes. And this is going to be skewed by the size of the database because this includes backups. So if you've got a really big data warehouse database that's not seeing that much IO, but it's just huge, it might be at the top here. So keep that in mind. And then the next one is going to show you, okay, which database is using the most memory and the buffer pool. And this can take a while to run in real life. Even on my machine, it's taking a few seconds. So come on, don't fail me now, machine. But anyways, it goes and looks at the buffer pool and reads the entire buffer pool and shows you how much that database is using. So I'm using about 32 gigs of memory for this one database, for example. So if you're under memory pressure, this helps you understand which database is the main culprit. All right, the next one in the set is looking at the version store for tempdb that gets used if you're using RCSI, for example. And I'm not using RCSI, but you have a little bit of usage by MSDB here. So that's kind of nice to know. This one is another useful one, the weight stats query, but people also misinterpret this very often. And this is going to show you the cumulative weight stats since SQL Server was last restarted or the query weight stats were cleared. There's a command you can use to clear them. And what'll happen is your server is running pretty well and nobody's complaining, but you decide to run this and you see this one right here, for example, and you Google that and you find some blog post or forum post from 5 or 10 years ago that tells you, oh my God, that's a terrible thing. You should do this and this and this. No, don't do that. What you want to do is run this if your server is running poorly, first of all, because if your server is running really well, you're always going to have weights, but they're not that important. And my workstation doesn't really have a real SQL Server workload. So all these weight stats are kind of unimportant. And if I ever see backup buffer or backup IO is my top wait type, that tells me on a real SQL Server that SQL Server is bored to death because its top wait type is database backups. And so what you want to do, and what you quite often see in real life, is CX packet is your top wait type. And people will, go look on the internet and find somebody who says, oh yeah, if your CX packet weights are high, you should change max stop to 1, and that will fix it. Well, yeah, it will fix it, but it disables parallelization, and usually that hurts your workload in most cases. So my point here is you can go ahead and run this query, but don't just start changing settings right after you do it. Do some more investigation and think about it and see if there's any other evidence to support your theory that, oh yeah, you're seeing bad IO performance, or you're seeing blocking or whatever because of this query. And these links over here go to the SQL Skills website, where Paul Randall has documented a lot of these weight types and what they mean and what, if anything, you should do about them. And so anyways, that's kind of my soapbox about the weight stats query, because so many people just do stupid things after they run this query. All right, the next thing is not that interesting in my workstation. This shows you all the connections by IP address, and these are all local connections. But in real life, this would show you all the different machines that are connecting to your instance and how many connections they have. And this sort of helps you judge your workload a little bit and see if it's normal or not compared to what it normally is. This one is very, very useful. It looks at your average task counts, and you want to run it multiple times and see if the numbers are jumping around. And this average task count, this is average across all your schedulers. If this is high, and by high, usually I mean above 10 to 15 on a regular size machine, that either means that your server is really, really busy, or you're probably seeing a lot of blocking and deadlocks. One of those two things, usually. And then if you see average runnable task count above 0, that means you've got runnable tasks that are waiting for CPU time. And that usually means you're under CPU pressure. And then this is sort of obvious. If you see average pending disk IO count above 0, that means you're waiting on IO tasks to complete, and you're probably seeing poor IO performance. And so just by running this, you get a really quick idea of what SQL Server is most unhappy about. Okay. And then if you did see those high average task counts, the next query in the set is very useful to detect any blocking that's happening right now. And you'll have to run it multiple times, because sometimes you'll see some blocking and you run it and it goes away. But if you run it and you keep seeing the same thing, it'll kind of show you which database and which statements and what resources are involved. So that helps you start to look into that. And then a new one that's added for SQL Server 2019 is this new page res cracker function that Microsoft wrote. And this helps you figure out if you're seeing different kinds of contention on TempDB. And of course, you won't see anything here now, but if you feel like you might be having TempDB problems, this will help you confirm that or not. And I've got a link to the documentation for it right there.
Glenn,
Yes.
there's a question. Is there any 2022 documentation on what various values should be, particularly considering its relationship to other values, as in balancing all the values that you see in the previous queries?
Well, I'm not quite sure what that question is really asking. I mean, SQL Server 2022 is very similar to 2019 from that perspective. I mean, there's a few new features and a few new DMVs that you have to learn to interpret, but most of the things like this one, for example, they're exactly the same as they've been forever. And I'd say probably 90% of the queries, the way you run them and what numbers are significant or not, are the same as they always were. Nothing really changed there. Just some of the very new things that were added in 2022.
And I mean, and also if you look at your weight stats, for example, that would be really depending on your workload and your environment and your hardware, right? There's a lot of, it's really it needs to, my number might be good for me, but it might not be good for somebody else's workload, right?
Yeah, that's exactly right. I mean, the
Yeah.
weight stats tell you what SQL Server is most unhappy
Yeah.
about.
Exactly. Yeah.
And it only really matters if SQL Server is unhappy in the first place. If your server is running really well,
Yeah.
don't worry about it. But if it's
Yeah.
running poorly and everybody's complaining about it,
Yeah.
it can point you in one direction or another to do deeper investigation, for example.
Does that answer the question, Kurt? Do you have follow up?
Okay. All right. So then the next one in the set, well, no, I skipped this query.
Sure.
So
Go ahead.
anyways, that's okay. This one just shows you, it goes back 4 hours. And in 1 minute snapshots, it shows you how much SQL Server was using of the CPU, which is 0 because it's just me talking. And then how much were other things that are running. So other things that are running in my machine are using 12, 13%. And in real life, I'd be unhappy if I saw that. You know, why are other things besides the SQL Server database engine using this much CPU on the server? And I'd pull up Task Manager to start with and try to figure out what is using all this CPU on the database server. But this helps you, you know, because usually you're sitting in your office or cubicle and you get a phone call or somebody comes in and says, "Hey, the website is slow. What's going on?" So the first thing you might want to do is pull up Task Manager. And then if you see the CPU pegged at 100%, you might run this query next. Has it been going on for 5 minutes or an hour? You know, and this would tell you, even if you don't have any kind of fancy monitoring system, this would give you a little 4-hour window back in time. Okay. So if you did see that it looks like you're under CPU pressure, this next query would show you which queries across the entire instance are using the most worker time. And worker time is CPU time. So it shows you which database, and then you get the short query text, and it's ordered by total worker time. And if you scroll over, you get a whole bunch of other metrics like elapsed time, and these are microseconds, not milliseconds. And then logical reads, how many times it's been executed. And then this query, this column is gold right here. This tells me that this particular query that's triggering this has a missing index warning, and it's my top CPU consumer. And of course, it shows you over here the creation time. And one thing I need to add to this query, I've been meaning to do it, is the last time it was executed. No, not that. Yeah, the last time it was executed. But anyways, the point here is pulling this from the plan cache. So it might not be 100% accurate if the cache got flushed for a particular database. But now I have a pretty good idea that, hey, this AdventureWorks database and this stored procedure is the most expensive, almost by a factor of 2 on the entire instance. And I'm under CPU pressure. So anyways, moving on, the next one, are you guys still there? I just lost something. Can you hear me?
Yeah. Yeah. We
Okay.
can hear you. Yep.
Yeah,
Yep.
I don't know. I was seeing something with some people on video and it disappeared. So I thought I lost the connection, but I guess not.
Oh.
So anyways, the next one is page life expectancy. And this is going to show, yeah, that came back. Yeah, that window disappeared for a while. But anyways, this shows you your page life expectancy in seconds for each NUMA node, and also tells you what time that you took the measurement. And you want to just watch the trend of this over time, because you can't just run it once and decide, oh yeah, I'm good or I'm in bad shape, you know. And there's easy ways to track this over time if you want to. Most monitoring tools do it, for example. But the higher this number is, the better. You know, and there's old guidance on the internet about 300 being the important number, and that's completely obsolete. It depends on how much memory you have, what your threshold should be. So higher is always better there. It's just a measurement of internal memory pressure. If it's low, it means SQL Server is hating life from a memory perspective internally. And then the next one is a perfmon counter that I'm probably going to drop pretty soon because it's not that useful in real life. But this is looking for memory grants pending from this perfmon counter. And this should always, always be 0. If it's ever above 0, that SQL Server is screaming bloody murder about memory. And it's very rare to see that. But if you do see it, you know for sure that you're under severe memory pressure because it can't get a memory grant to run a query, for example, is what that means. All right, the next one is very useful. It's the memory clerk usage. And this shows you what memory clerks are using all your memory. And on SQL Server 2012 and newer, you want it to be this SQL buffer pool. That's your SQL Server buffer pool where all your data is cached in memory. But you might see other things like cache store SQL CP can often be a very high user of memory. And this is the planned cache for ad hoc and prepared queries, not stored procedures. And if this is really high, that can be a problem. And there's ways to help control that, like turning on optimize or ad hoc workloads helps. And then there's a command you can run right here, dbcc free system cache SQL plans, and that will flush just that one cache. And I have that on an agent job on many customers every hour, for example, just to flush that cache. And it really helps you from wasting a lot of memory in that plan cache. All right, so if you did see a lot of things in that particular plan cache, you can run this query to figure out, okay, who's doing it to me? Why is that happening? And this shows you all the ad hoc plans that have a use count of 1. So they've just run one time. And you can see what database they are and what the query actually is and whether it's ad hoc or prepared and how big it is, and whether it has a missing index warning. So if you saw something from one of your main databases with a big, huge plan and lots of things here, you would go talk to the developers and say, hey, what are you doing here? Can maybe we convert this to a stored procedure or parameterized query that doesn't show up as an ad hoc or prepared plan because it's wasting all this thing and it's not being reused. So that's what you would do there. All right, the next one in this little set, if you felt like you're under memory pressure, look for the top logical reads queries across the entire instance. Excuse me. And again, it shows you the database name and the query text, and then it's ordered by logical reads. It means it's finding stuff in memory, but it's having to do a lot of scanning through your buffer pool to find it, and it's causing memory pressure. And you get a lot of other metrics about it here, including the execution count and whether it has a missing index warning. And I love to see these missing index warnings because that's something that I can usually fix myself really quick and sometimes make a huge difference. And everybody thinks you're a super genius because you made this difference and all you did was some index tuning. So this helps you find those. All right, the next one in the set, this one takes a long time to run in real life sometimes, but it's looking for the queries that have the top average elapsed time across the entire instance. And again, these elapsed times are in microseconds, not milliseconds. But if you've got some query that, is taking 10 minutes or 30 minutes or something, and you spot it here, and then you get lucky and there's a missing index warning, maybe you can make a big, big difference. Or maybe you can go in and, tune that query and make a big difference. But this helps you find those possible, candidates for your attention. And then scalar UDFs are really evil for SQL Server. This is a pretty well-known fact, but it's not well known by developers usually. They like UDFs. So this will show you what's going on with UDFs across the entire instance. And of course, Microsoft is an offender in MSDB. They've got some system scalar UDFs right here. But in real life, usually, once your developers find out that scalar UDFs exist, they lose their minds and use them a lot because they're very easy, but they cause all sorts of performance problems. So this helps you spot that. Okay, and then this is another new one. Ever since SQL Server 2016 SP3, they keep track of this. If a buffer pool scan takes more than 10 seconds, they'll note it in the error log. And they made an improvement in SQL Server 2022 to use parallel buffer pool scans. So this is another way to help build the case to upgrade to SQL Server 2022. If you run this on your old instance, as long as it's a new enough build of SQL Server, and you see lots of long buffer pool scans, and this usually is a problem on machines with lots of memory, but you can see it even if you only have 64 gigs of memory. But if you've got 2 terabytes of memory, it's very frequent to see this because only one core is doing a buffer pool scan. So that's what this helps you find. So those are all the instance level queries. Sounds like there's a question.
Yeah, there's a question here. Tom says he mentioned Brent Ozar mentioned to ignore page life expectancy. Tom, is that?
Well, yeah,
Yes, that's
Brent,
what I seem to recall.
yeah, well, Brent might have said that, but I would disagree with him. I mean, I know some people don't think page life expectancy is the only thing to look at. And I'm not saying it is, but I find it to be useful to see what's going on with internal memory pressure. Because what it's measuring is how long data is in the buffer pool before it gets flushed out to disk. And if it's a lower number, that means you're under a little bit of memory pressure.
Yeah, because you actually do a lot of hard read to the data, right, to the disk instead of from memory, right? There's a lot of
The
turnover
lazy
there.
writer is going around and finding stuff that's been in buffer pool for a long time and writing it out to disk. And higher is better. I mean, I disagree. I don't think Brent said to ignore it. He probably had a bunch of caveats, about it. I don't think he would ever just say ignore it. But anyways, the next bunch of the queries are database specific. And so make sure, that's why I say use your database name. And I've actually gotten emails from people saying, but I don't have a database with this name. So hopefully you don't make that mistake. Just change it to the database that you care about. And we know, or at least I know, that this particular database is the main culprit on my workstation. So make sure you switch to it. So now this first query is just going to show you what's going on with the files on that database, how big they are and where they live. Is it the default file group, for example? So that's kind of nice to know. You really want to know, is it full? Is your log file full? Is your data file full? Does it have a lot of empty space inside? The next one's going to show you what's going on with the log space usage. And this was something they added back in SQL Server 2016, because they could make it, if you wanted to, you could pay attention to this and you could decide to have transaction log backups run based on how much of the log was used rather than say every 15 minutes. Not too many people use that, but if you wanted to, you could use this DMV to figure that out and then kick it off more often or less often based on that. And this is also useful right here, the last VLF for your log file. If you're trying to shrink your log file, because say you had a runaway transaction log and you ran out of disk space, and then you're trying to go back in and clean it up afterwards, and it doesn't want to shrink, this will help you understand why it won't shrink, is why it's useful. And then this one is also new in 2016, so it's been around a while, but they keep adding more and more stuff here. This is database scope configuration values. So these are things that you can set at the database level that back in the old days, you had to set at the instance level or use a trace flag. So for example, max stop, you can set max stop to a different value for each database if you want to, and you can set it to one value for your primary and an AG and a different value for the secondary replicas if you wanted to. So when SQL Server 2016 came out, you only had these 4. And then they added this one in 2017. And after that, they kind of went wild. They added about half of these in 2019 and about half in 2022. But more and more things, you can control the database level instead of the instance level. So this tells you what's going on with that. And in my experience, a lot of people have no idea about this. They don't even know this feature exists. Okay, this shows you what's going on with the IO stats for each file in the current database. So again, this helps you figure out, is it more of a reporting workload? Is it more of an OLTP workload? Rather than guessing, you've got numbers. And this helps you decide how to do your storage and how to do compression and how to do indexing. This shows you which queries on this database only are being executed the most often. And so you get the query text and the execution count and a bunch of other metrics, including the missing index column. And then here's when it went into the cache, and here's the last time it was executed. And this is very useful to look at, because if this is just a few minutes ago and it's changing a lot, that's another indication that you're under memory pressure. Because if you're under memory pressure, SQL Server is going to start throwing plans out of the cache to try to free up memory. So that's another way to figure out if you're under memory pressure. And this shows you the last time it was executed. So again, this helps you find what's being executed the most often, which may or may not be that important, but it's nice to know. And then right here, I've got a little subset that I call the bad man list for stored procedures. And it helps you figure out what stored procedures in this database are causing the most pain from different perspectives. And the reason I call them the bad man list is back when I worked at NewsGator long time ago, I would collect these every couple of weeks and stick them in a spreadsheet and then send them out to all the other developers and DBAs. And we would work together as a team to tackle whoever was at the top of the bad man list. And if you do that through several iterations, I guarantee you will improve performance, because it's showing you which things are the most expensive and you're doing something about them. So anyways, this shows you which stored procedures are called the most often and how often they're called, and then some metrics about them: elapsed time, worker time, logical reads, missing index. That's gold. That's easy fix many times. So now I know that these ones are something I need to look at. And usually you just want to look at the top 3 or top 5. Don't worry about number 22 that much. So that's for execution counts. And the next one's for average elapsed time. And again, these elapsed times are in microseconds, not milliseconds. And this is sorted by this. So this showing which ones are, taking the longest, and people might notice if you do something about them. And then the next one is for total worker time. And this is showing what's causing the most CPU pressure. So if we were under CPU pressure and we know which database, now we know which stored procedure in the database is the big villain here. And it has a missing index warning. So that's easy money. All right. The next one is the same thing for logical reads. Shows you what's causing the most memory pressure. And you probably are starting to notice that the same 2 or 3 stored procedures are causing most of my pain. And this happens a lot in real life, which is nice. And then here's the same thing for physical reads. It means it's having to go out to disk to find what it needs. And here's the same thing for logical writes, which stored procedures are causing the most write activity. And you can kind of tell by the names, right? And then this one shows you which cache stored procedures in this database have missing index warnings. And one thing I've been skipping over here, see right here, this one line is commented out on purpose. But if you uncommented it, it would actually show you the execution plan for these last several queries. So you could click on that and see the execution plan and get an idea of what its main issues might be. And if there was a missing index warning, it would give you the details of it. So this is really useful. And again, I've got these 6 stored procedures, all have missing index warnings, and I could start to, decide what I'm going to do about it to fix it. And then the next one in the set is top IO statements. And this shows you which statements in regular queries and stored procedures are having the most IO. And it shows you the stored procedure if it is in a stored procedure, or here it's in a function, for example. And here's the query text, and then the average IO and how many times it's been executed. And a lot of times this will show me things. You'll see things like people aren't schema qualifying tables and they're using table variables. You see some of the actual T-SQL in here for these big offenders. And then this, I've been talking a lot about adding indexes. Well, this helps you find indexes that maybe you can drop. So this shows you non-clustered indexes that have more writes than they do reads. But again, that's really important. How long have you been running? Have you been running long enough that your database has seen the complete business cycle for your application? And usually that might be a week, it might be a month. But if you've been running long enough that that's the case, and you come in here and you see indexes with millions of writes and 0 reads, and these are non-clustered indexes, they're not clustered indexes, then it's probably safe to go in and drop that index. And if you do that, that's going to get rid of the work to maintain that index and make you the writes to the index quicker and make your database smaller. So that's very useful, and people tend to neglect that. I see so many databases where there's hundreds of unused or underused indexes that aren't giving you any benefit. And then here is the missing index query, just filtered down to this database. And somebody drew on my screen there. So anyways, what's going on here is I added a couple new columns to this. So I show the table name over on the far right again, and I show how many rows are in the table. Because if you're on SQL Server Standard Edition, you don't have online index operations, and you've got to be much more careful about creating new indexes. And this is going to vary based on your hardware and what version of SQL Server you're using and some other factors, but you'll get a feel for pretty soon, if you're a production DBA, for how big of a table can you get away with creating an index on with nobody noticing. Because my mantra as a DBA has always been, nobody should ever notice anything that I'm doing. If I'm doing index tuning or configuration changes, I don't want the database to just suddenly freeze up for 30 seconds in the middle of the day. And everybody like, oh, what happened? I don't want that to happen. So I'm really careful. If I'm going to create an index and I don't want to take an outage to do it, I want to know how many rows are in there before I do it. So that's why I do that. Okay. So then the next one in the set, and we're getting pretty close to being done here, is missing index warnings. And this can take a long time, many minutes to run sometimes in real life. But it shows you queries and store procedures and functions that have missing index warnings in the plan cache. And it shows you how many times it's been executed. And you can click on this and get the execution plan, and you can right click and get the missing index details and what it thinks about it. And you can't always believe this green, but it gives you a starting point. So it's just another way of finding possible things that you can easily fix as a DBA. And then this next one, buffer usage, it shows you what indexes are using the most memory on your instance for this database. And this can take a long, long time to run in real life if you've got a lot of memory. And even on my machine, it took a few seconds there. But in this case, it's showing you, on the primary file group, this table, index ID 1 is the clustered index. It's taking 186 megabytes, and it's not using data compression. And what's kind of interesting, at least to me, is I have another table that's exactly the same as this one, but I used page data compression on the clustered index, and that only takes 43 megabytes in the buffer pool. And you'd see the same thing, you'll see it on the next query on disk. And so data compression is a very, very useful feature that's in standard edition since 2016 SP1, and not that many people use it. And it just blows my mind that people don't use it. It's a huge win in a lot of scenarios. And this helps you find candidates for it. So here's another one that helps you find candidates for it. It just shows you, okay, what tables in the database are the biggest on disk. And this is showing you how big these tables in this particular database are on disk and how many rows they have, and the fact that they're not using any compression. And in real life, on a big database, you might come in and see some table that's using, hundreds of gigabytes or terabytes, for example. And a lot of times you can tell by the name. So this is a table called event log. And a lot of times log tables like this, what you do is you just insert a row to it over and over and over again, and you never update. It just gets inserted. And a lot of times those sorts of tables are great candidates for data compression because they're not really very volatile. You're just doing inserts and they're large. And there's a system stored procedure called SP estimate data compression savings that you can run to see how compressible it is. And you might run that and it comes back and says you're going to get a 6-to-1 or 8-to-1 compression ratio. So that might be golden. If you get an 8-to-1 compression ratio on a 1 terabyte table, you're going to save, 900 gigabytes of space. And that can be huge in a lot of scenarios. All right, so going on after my little sermon about data compression is some table properties. And this just shows you what's going on with all the indexes for each table, whether using data compression or not, because there's no compressed database function on purpose. You need to look at every single index separately. So this is just showing you a bunch of information about every single index and every table in the database. And then this next one is statistics update. It shows you last time that statistics were updated on indexes and stats. Because if somebody is disabled auto update statistics and they're not doing enough manual updating, you can have a problem that gives you bad query plans. The next one shows you which indexes are the most volatile. And this helps you decide about indexing and data compression. If you've got a fairly small table that's really, really volatile, lots and lots of updates, inserts, and deletes, you might not want to use compression on it, for example, and you might want to not have as many indexes on it, for example. So this gives you an idea of what's going on. Here's the modification counter that it's using to calculate that. And then here is fragmentation. And I know Brent Ozar says, don't worry about fragmentation, but it can still make a difference on some sorts of queries. And of course, I don't think you should be just rebuilding indexes every single night. That's stupid. But I don't think you should completely ignore this either. It depends on the table and what kind of queries you have. Certain range scan queries are affected by this, and solid state storage makes it less important than it used to be. I don't argue that either, but that's what this query tells you. All right, the next one is which indexes in this database have the most reads? And these are the ones that are really valuable for select queries. And this helps you decide things like maybe you want to compress that index. It also tells you whether or not page locks are allowed. Because if you don't have page locks allowed, you can't reorganize the index. All you can do is rebuild it. And it also can cause more blocking issues. This does the same thing, ordered by rights. So which indexes have the most rights? This also helps you spot ones that have lots of rights and 0 reads. Okay, the next one, if you're seeing locking issues and you don't want to use RCSI yet, maybe, or you're seeing blocking and deadlocks, this will help you start to figure that out. Shows you what indexes have the most lock weights, and I don't have any here, unfortunately, but on a real database in real life on a server, you'll probably see some lock weights, and it shows you row lock weights and page lock weights and index lock promotion attempts. So it helps you get an idea. And usually the way you fix this, in my experience, is rather than using no lock hints or read uncommitted isolation, you want to go and do index tuning. So if you have a non-clustered index that it really needs and you give it to it, it'll avoid doing a table scan that causes all sorts of locks, for example. All right, the next one is looking at UDF execution statistics for just this database, and there probably won't be any but in real life, you quite often will see some there. And then SQL Server 2019 added a new feature that let you automatically inline scalar UDFs. And it doesn't work as well as they promise it would. And there's been a lot of bugs with it. But if you're on a current build of SQL, it helps a little bit on some of them. So this would show you UDFs that can be inlined automatically. It depends on how complex they are and what they're doing exactly, whether they're inlineable or not. And then this shows you whether or not you got query store enabled or not for this database and what options you're using. So what you want to pay attention to here is what your max storage size is and what your current usage is. And then you want to have it set this way using custom and auto. And there's some guidelines from Microsoft, and Aaron Stellato, I'm sure he'll talk about that in a couple of months here. But it's important how you set up Query Store to make sure you don't run out of storage here and have it go to read only. And then the next one in the set is input buffer information. So they added this back in, I think, 2017, but it shows you your input buffer for all your SPIDs. And it doesn't truncate it like DBCC input buffer is. So you can get the last command that is executed on that SPID and see some stats about each of your SPIDs. So that can be useful sometimes. And then there's a new feature they added in 2017 and they enhanced it in 2019 and 2022. It lets you do resumable index rebuilds and creation now. So if you had that going, this would spot that, oh yeah, I was trying to build an index on this huge table and I stopped it. So now I can find it again and not just forget about it with this query. And then here's another feature they added in 2017, automatic tuning, and it relies on Query Store and it's Enterprise Edition only, but you can turn that on if you have those two prerequisites. And what it does is it looks for execution plans that regress from a CPU perspective, and it goes and tries to come up with the last good plan before that happened. And then it checks to make sure that that didn't make it worse. And it automatically does this. So basically it automates you going into Query Store and freezing a particular plan. And it only looks at CPU. It doesn't look at other things. And then this is the final one in the set. It's looking at the last full backups for this database. And I'm actually going to switch to this database because it's more interesting. But it shows you what's going on with your database backups. And you can see the uncompressed size, and then the compressed size and the compression ratio. And then this is new in 2022. It shows you what algorithm was used. And you can see it's using backup checksums, which is good, whether or not it's copy only or not, whether it's encrypted or not, and how long it took, and when it finished, and then where it's going to. And if you see something here, like it looks like a GUID instead of like a UNC path or a drive letter like this, that tells you that something weird like Veeam, some external process is doing backups that you may or may not know about. And it's important you know that, because if you're trying to do something like log shipping and you've got something like Veeam doing log ship backups that you don't know about, that's going to break your backup chain. And this will help you catch that. Not to mention that it's just nice to know what's going on with your backups. Are they getting much bigger? Is the compression ratio really high? Because, for example, if you're not using any data compression on your database and you see a really high compression ratio on backup compression, that tells you that your data as a whole is highly compressible. So you might want to start looking to see if you can use data compression. And of course, if you start data compressing indexes, your backup compression ratio is going to go down because it's already compressed. But again, I can't talk up enough data compression, how useful it is, especially if you're on standard edition and you're limited by how much memory you can use by the Microsoft license limits.
I have a question, Glenn, on that. Does the page kept in memory compress until it needs to be read? right?
Yeah.
If I'm not mistaken. Okay.
Yep, that's how it works. So if you've got an index that's using page data compression, it's compressed on disk. And if you read it into memory, it stays compressed. And the only time that gets uncompressed is if you change the value. So if you do an update, it has to decompress it and then change it and then recompress it. So that's why the guidance is you want to try to avoid using compression if you have a really volatile table. But the thing is, a lot of the guidance you'll see from Microsoft was written 10, 12 years ago when data compression first came out. And modern CPUs are a lot more powerful than they used to be. And so it's a lot safer and less impact to your CPU, even if you do have a pretty volatile table. And so, yeah, data compression is valuable, and so many people don't even use it.
Yeah. Awesome. Thanks.
So, I finally finished there. So if there's any other questions that came up, I'd be happy to answer them, or you can email me, or reach out on Twitter if you think of something later.